Let's have a look at soldering techniques for electronics. We'll start off with some things you need to think about. Tip selection. You can get a wide range of styles, but I'd suggest using a chisel type, which you can get in different sizes. They provide the best versatility because you can have a small or large contact area depending on the size of the thing you're trying to solder. The round style is okay as well, but it's a bit less versatile. But if you've got a lot of things of the same size, then that will be suitable. I suggest using T12 types like this or similar that have the heating element integrated into the tip. They heat up and control the temperature much better than the older style that has the element separated from the tip. The soldering iron maintaining a precise temperature is critical for good results with lead-free solder. If you're using lead solder, it doesn't matter as much. A temperature-controlled soldering iron is preferred, and usually you'll want that set to 350 degrees Celsius. That will be suitable. Lead-free might need a bit more depending on the solder formulation, but generally 350 degrees is fine. You should keep your tip tinned at all times. Solder selection. I prefer a good quality lead-based solder with flux in it. You can get different diameters depending on whether you want to do fine or heavy work. Makes it easier, but you can also control that by how you feed the solder into the join. Lead solder is preferred because it is easy to work with, not fussy with temperature, and produces slightly softer solder joints which are less likely to crack. If you must use lead-free, a high quality, high performance formulation is recommended, like SN100C. This will give you the closest handling and performance results to lead-based solder. Soldering iron tip preparation. You should always keep the soldering iron tip tinned. You wipe it on a damp sponge, or a rag would suffice if you don't have a sponge. Just quick like that. Best to wipe it before you use it. And if you're not going to be using it for a while, leave a little bit of solder on there to keep it nice. The gold colored wire wool is a better choice than a sponge because it leaves more solder on the tip, a nice thin coating, and it does not thermally shock the tip like touching the cold sponge does. Now let's solder something. Got a kit here that I found hidden away that has never been assembled before. It is flashing lights, or flashing LED. It's a astable multi-vibrator circuit, and I've got these instructions on how to put it together. Fairly straightforward. You'd start with the lowest profile components first. There are two values of resistor in use here, 1K and 10K, and they give you the color combinations to work that out. The 10K will be these ones with orange, and the 1K are the ones that have got the red. So R1 and 2 are 1K. I'll grab those, form the leads, and you can get a tool to do that, but after a bit of practice you'll work out how to bend them nicely. It says R1 and 2 1K, R3 and 4 10K. The orientation of the resistors does not matter, but it is nice if you have them all lined up around the same way. So we'll just push that down, we'll clean the tip, and get our lead-based solder. Now the technique is very important here. What you need to do is apply heat to the things you want to solder, then after a short delay, to give them time to heat up, then you feed the solder in. The reason you want to do that is because there's flux in the solder, and you want the flux to be activated by the heat on the thing that you want to solder. The flux will clean the surfaces and allow the solder to adhere to them. So we apply the heat, then apply the solder, then remove the heat. Apply heat, apply solder, remove the heat. We'll push down on the board, which will help the components to sit flat. Heat, solder, remove heat. Heat, solder, remove heat. Pretty easy. should be working up here so we can see it better. So this board is not plated through, it's only got copper on one side. There's no copper going through the holes. If you're using a board that has plated through holes where the copper goes right through into the other side, then you'll need to apply a little bit more solder because it's got to travel through to the other side. So you can use your hands to hold it, and index finger and thumb hold the solder and direct it, and the other fingers to hold boards or other things. Great! Resistors are attached. You'll clean the soldering iron, put it away. Once you've done the soldering, then you need to trim the legs, unless you're using surface mount, but side cutters like this, and hold onto the legs with your finger, otherwise they'll go flying away, which can be a bit dangerous. And you can keep these to use later on where you need to make little wire links, so they're useful, you don't need to throw them away. Now the next part is these trim pots. There's two of those, they're both the same value, 220K, so they're pretty easy. They only go around one way. Looks like they've catered for two different footprints. You can have a type where the three legs are together or where they are apart, like this one. And the track there just goes between them, so either type will work. Let's use some lead-free solder for these ones. I have here some SN100C, I think it's 0.8 thickness. There's this one here, the lead solder I used was 0.6 millimeters thick diameter. So we'll try some of this SN100C. This stuff is the industry choice for lead-free hand soldering because it performs very similarly to lead solder. So same thing, heat it up, apply the solder, remove the heat. If necessary, you can use the soldering iron to help to move it around a bit to help the solder flow all the way around. We've got some transistors next, BC547, both positions. If you want to know how to hook these things up and also to test them, you can get quite cheap these component testers. So you just plug it in any way around into the socket. It's got their 1, 2, 3 labeled, and it will test, and then it will tell you what the 1, 2, 3 is. So 1 is the collector, 2 is base, that's the middle pin, and 3 is the emitter. Transistors. So we'll put those in. And be careful with these things, not overheat them. We might as well put the capacitors in at the same time. Electrolytic capacitors, which have a polarity, which you need to have right. So they have one longer leg for the positive, shorter leg is the negative, and they also indicate with the stripes down the side, which is the negative side. And then on the circuit board there, they put a little plus. So we know the plus is the longer leg. The other one's the negative with the bands down it. Same again, plus. If you're designing a board, you'd usually want to get all the capacitors, the electrolytic capacitors, around the same way so the negatives all point in one way. Makes it easier for inspecting the board after production. Apply the heat, apply the solder. Okay. Now we use the lead free for these capacitors just for fun. Lead-free solder is usually thicker, it won't run as easily, or has higher surface tension. So if you get a bit too much solder on the join, you can pick it off. So we can test that there. If we put a massive blob on there, so it's messy, clean the soldering iron tip, reheat it up, and just drag it away, and then clean that off. You might have to do that a few times, but you can get it tidy. Trim these legs. And then finally, we've got a battery connector, and there's LEDs. Similar to capacitors, these have to go around the right way. Similar to capacitors, the positive lead is longer, which is the anode, and negative cathode. Then it has a little flat part on the body, which is quite hard to see here. There is a flat part on the body there, which is also the negative side, or the cathode. And they show the flat on the symbol there, so that makes it easy to assemble. Got to make sure they're right way around before you solder them. Good. Other legs. Good. Trim those. We're ready for the battery connector, but we've got a problem there. That's where the battery connector goes, red, black. But we've accidentally got some solder on that hole there, so we can't poke the wires through. So how do you fix that? The easiest way to fix it is to use some de-soldering braid or solder wick, which is a copper braid. See there, it expands out when you press it, and that has flux in it, and you heat that up over your solder and it will absorb it. It absorbs the excess solder. So if we put that down and hold the soldering iron over the top, once it melts, you'll see the solder starts soaking along the braid, and it's now uncovered the hole. So you can use that for removing components as well, although it can be quite difficult, especially if your board is through-hole plated and the solder goes through the holes. It will be quite difficult to remove, in which case there are other tools you can use, like a de-soldering pump, which provides a suction. So to use that, if we wanted to desolder this connection here, if it's an old board, you'd usually want to apply some fresh solder to get some new flux into it. So yeah, you also need to support it. That you melt the join, and then you put this over and press the button to trigger the suction. And there you go. It sucks away all of the solder. And then what you have to do is hold this over a container of some sort when you're pressing the plunger back down, because it will eject out the solder that it sucked up. So that's a useful tool. In more industrial environments, you'll find motorized vacuum pump desoldering tools similar to this, probably a lot newer and better performing than that, and that will allow you to desolder things much easier, especially where through-hole plating is involved. We'll just solder back that one we sucked the solder away. Okay, we'll put the battery connection on and then we'll try this out. The wires came pre-tinned, so they were stripped and then already had solder applied to them, so they were easy to solder. If you're preparing new wires, then you'll want to tin them before you solder them. I don't know if I've got any working 9-volt batteries, but let's find out. Oh yep, first try. So it's an astable multi-vibrator, so it's not stable in any state. And we've got adjustments here which will change the rate that capacitors can charge and discharge. So according to this diagram here, got the variable resistors there, and that will control the rate that these capacitors can charge. So you can make one side very short and the other side very long, or you can have them very similar, or you can have it around the other way. Hours of fun. Okay, let's look at preparation of cables. Okay, I got a big bag of alligator clips here and some nice flexible instrument cable. So let's make some clip leads. Let's make a white one, since we've got white wire here. Makes more sense, doesn't it? So we'll make a short clip lead. There's strip wire. Normally you just use cutters like this and hold them back so that the blades will dig in. Always twist it. Do the same on the other end. Always twist it. Always tin the wires, which means adding some solder to them. And you need to develop a technique so you can hold them and hold the solder at the same time. All we need to do is heat up the wire and then feed some solder into it. And you want to be feeding the solder into the wire, not into the soldering iron. So that puts a nice coating of solder onto the wires and into them. Very important. So these clips have a little fork thing for crimping around the wire. They have a hole there which presumably you poke the wire through and then you can solder it. But a lot of the time I just solder it down on the inside in there, and that works good enough. Restrain it somehow. Clipping it onto that is a good way. Although if you heat it up too much it's going to bite through. This is where your biggish chisel tip comes in handy, because you got to get a bit of heat into the metal and then feed some fresh solder in there so the flux does its job and tins the inner surface. And then you can apply, just trim that down a little bit. Push the wire into the soldered metal, heat it up, hold it completely still until the solder solidifies, and then be careful about touching it because it will be hot. But that is soldered in there now. I'm going to be careful about it so you don't melt the insulation, and also be careful that you're not soldering onto the end of the spring that's in there, because that will move slightly when you squeeze the clips. And just heat it up. Keep feeding in a little bit of solder every now and then until it starts taking. It'll take a little while to heat the clip up hot enough. And that one's turned into a little bit of a mess. and stick your wire in, reheat it. If you've tinned the wire and the thing you want the wire to solder onto, you don't need to add more solder to join them because the flux has already done its job and cleaned both surfaces when you were tinning them. I made the classic mistake of not putting these covers on. It's important that you put the covers on the wire first. So we'll just squeeze the little forks down to hold the wire so we're not relying on the soldering. And then find something to clip this onto that makes the little handle bit squeeze down, and then push the cover over it. Perfect clip lead. That's a very slippery one though. It's probably better off using this to hold it so it doesn't melt its way into the solder spool. Go, it's starting to melt, so apply a little bit of fresh solder in there. That's created a nice little pool of solder in there, and we got some nice solder on the wire already. So we'll just reheat the two, push them together, hold them completely still, although the ruler's slipping away. Very good. And you just crimp the forks down, and then put the cover over it. Good clip lead. I found this wire on AliExpress very cheap, and the one I got was 17 AWG. So there's reels inside here. I think it's a couple of meters long, so we can use this to make some different colored clip leads. This wire has a lot of strands, so that's quite nice. We'll make one of each color. Okay, so again, I think we can do them all at once. You just squeeze it, pull. This is a silicone wire, so it's pretty easy to strip the ends, and then twist, and then we'll tin them. It's very important to twist them, otherwise you get loose strands that splay out and go in the wrong places, and that can cause short circuits and issues. So you've either got to twist them or crimp them into something, or put ferrules on. So tin the wires first. It should soak up quite a bit of solder, these, because it's very fine strands, so there's lots of space between the fine strands for the solder to go into. Be mindful when you're doing that, a big ball of solder will be forming on the tip, so you can drop that off into your sponge. So they are all nicely tinned now. They might need to be trimmed a little bit depending on how much space you've got in the clips or wherever you happen to be soldering them. And we need to put the covers on, although we haven't soldered the other end yet, so it doesn't matter that much, but let's just do it now. So they're ready to go. Need to heat it up until the solder starts melting into and flowing onto the metal. There it goes. Put a bit more on there to get some good flux into it, and then we'll push our wire into it, reapply the heat, and then hold it perfectly still till it solidifies. You can see when it solidifies because the reflectiveness of the surface of the solder slightly changes. It goes from very shiny to slightly less shiny. The smoke, which comes from the flux burning, is a problem. Then you can use an extractor fan or just a normal fan to blow it away. You can get smoke absorbing fans if you're in an poorly ventilated area to filter out the smoke particles, or do your soldering in a location that has good ventilation. Just redo that. You've got to be careful if you're holding the wire, because the heat will travel up it and can burn your fingers. Just freshen that up a bit. Hold it still. Good. This is quite a bad demonstration because you can't actually see the soldering taking place in here. We'll get our tinned wire, push it in there, heat it up, hold it still, wait for the solder to solidify. Perfect. So that's cooled down now. It's soldered, so we'll crimp the wire into position. And then fit the cover on it. You can do it with your fingers if you can deal with that. So there's a nice half of a clip lead there. That's good. We'll crimp though. So hopefully that's covered the basic techniques of soldering with some useful information that you can use to make great things.